Okay, graphing A, we're going to be dealing with quadratics here, so I have the arch here at St. Louis. It's a parabola, and we're going to be talking about what the A means in the quadratic. And A is the value in front of the x squared. In this case, there's not a number, which technically there is. It's the number 1. And if you were to go put this in your calculator and you go look at your tables, and you probably dot is 0, 0, and obviously 1 times 1, 1 times 1 is 1 squared, so it's 1, 1. 2 squared would be 4. Actually, like I said, negative 1 squared is 2 squared is 4. And negative 2. Remember, it's negative 2 times negative 2 is 4. 3 times 3 is 9. And negative 3 times negative 3 is 9. So you'd have a graph that looks like that. That's plotting the points, graphing it. This is our normal x squared graph. Well, what would happen? And that's what we said. This is the number 1 here. It shows up. We just don't write the 1. But what would, and you also see this here on the parabola, that it went up 1 over 1 to its first point here. That only happens on the parabola for the first point when it's over, like in the sense of the 1. So for the first value. All right. Now, let's look at this here. Suppose this was a 2. What would be different? Well, your 0, basically you have your y value here, and you're going to take 2 times it. Notice all the y values in this 2x squared are doubled. The x values are the same in both charts, but the y values are double because you're taking 2 times whatever the y value is. You're doing the squared first, then taking it times 2. So obviously 0 times 2 is 0, but 2 times 1 is 1, and you'll see this happen, that our graph kind of in a sense doubles, and if I had 18, it would go way up there. Also, I want you to notice this. It's a 2 for this x squared, that the distance for that first point only is up 2 over 1. Now, it's not the case for the second point or the third. It's just that first value if you're not talking about fractions here. And a unique way to help me figure out kind of what the a value might be just kind of by looking at a graph. All right. There's the normal one, and you can see the normal one, x squared one, and the 2x squared one. All right. So what we want to talk about is this. Those are vertical stretches. Notice it says the a value greater than 1. And by that, we're talking the absolute value of 1, meaning we're talking about, we're just looking at the value as a positive only. If it's larger than 1, it's a vertical stretch, meaning I call it the graph got skinny. That graph got skinnier. If you look at it, that 2 is a skinnier graph than the 1. All right? So that's called a vertical stretch. Okay? Now, let's look at one with a 4. Well, once again, here's my normal x squared graph, y equals x squared. And notice the x values are the same, and the y values are 4 times as big as the y values here because you're taking it times 4. So we still have 0, 0. And the thing I really kind of wanted to point here was what? Notice it went up 4 over 1 to that first point that's over 1. And it's a vertical stretch. It's a vertical stretch. Okay? But what happens when I have a negative 3? Well, look at the, first off, here's a negative x squared. Notice it's different before. Before I had all positive y values. Now I have all what? Negative y values. And then if I take negative 3 times my x value here, well, we should get that same there. You end up with values that are just 3 times as, going down 3 times as fast. Notice this one went down 3 and over 1 as a kind of slope for that first point. It's kind of interesting. This is still a vertical stretch, but it reflects across x. This a did 2 things. It's the absolute value of it is larger than 1 because the absolute value of negative 3 is a 3. So it's still a vertical stretch, and because it was negative, it reflected across x. You're going to need to do that like on your test anytime you have a negative. So here's our normal one. But what happens when I have this right here? This is 1/2. Okay? This is the absolute, it's going to show up here. This is 1/2 x squared. All right? And what happened here is this is kind of hard to see it. As we went over one whole unit, and that's this darker line here, I kind of had to make my graph special, it only went halfway up. It only went halfway up as it went over one whole unit. That's how come I noticed this graph was 1/2. It's not really the best way to kind of do these. It's kind of hard to see. But at 1, it was actually only halfway up of the way to it. And if you'll notice, these graphs here are not going up as fast. These graphs got wider or fatter, and these are called vertical compressions. The vertical compression is a graph that is fatter. I'm not supposed to use the word fatter. it's wider, it's not going up as fast, it's a vertical compression. And you'll notice we had 1/2 for an A value. So that's smaller than 1. All right, now negatives, you be careful. I mean, -3 is smaller than 1, but it's not smaller than the absolute value of 1 because it becomes a +3. So if your value is a number larger than 1, it's a stretch. If it's smaller than 1, it's a compression, as long as we're looking at the positive only. And if it's a negative, it will reflect across the x-axis.